Hello everyone. In this video we'll continue to build our building. We will design the structure in 3D. So we go to the grid here, and then here we define the interact, the space between frame. So we have 10, so we will have a structure about 40 meters. It's a big structure. So we are done. Now we can select and we can copy it from edit, move or copy. So we can choose here, this is our 3D model. Next step, we will define the burden. I will decide to put burden EBE 100 or EBN 100. In the next video, we'll see how to add a burden like sigma ZC, for example. So I have 100, it's okay. So I can add it from here. Other thing I can do is axis position. So here I can define axis position, offset, burden, okay. So here I have 100, here I have 330, so it could be we'll try, and here we will define so we can define here bracket, not a bracket, offset. I make a mistake, it's not 100. It's 100. I change the section. So here I can put but it is not appear quickly in the model. I have to change the parameter here. So offset here, apply, as we can see So we have in first time we have to change the angle. Here I suppose it is 15. Not this. Offset. So we are okay like that. Second step, I have to define all the burden along the frame. So the ideal space between burden is about 1 meter 30 centimeter. 1.3 meter is the ideal space. And then if the burden is surcharged, or there are a lot of charge in the burden, we can add we can reduce the space between burden, or we can raise the section EBE 120, for example. So for define the burden, I need to define node. So divide, generate node. So the first one can be a 20 centimeter. It's about and the second this. And the last one is 1 centimeter. We are okay. And what can we do later? Now we have to do copy. So it is important to choose a good section here. We have here, there are two kinds of flexural effort here. We have composite flexural in the two side of a plan. We have in a plan of XY and a plan of XZ. So for this reason we will put a round here from this purlin to this purlin. We put a steel member. It can be a cornier to support the lateral buckling. When we limit the lateral buckling, we can reach to stable structure, because as we can see, the purlin is inclined about 15 degrees. It is laid about 15 degrees. So we can put coordinate. It's 20 multiply about 20 by 3. So we can put cornea about 20 by 13. It's not bad. So here, as we can see, like the structure is symmetric, so we can do that. So we can do copy by symmetry for the other side. And the same thing, we have two type of effort. It's not the same way to the frame. So we have vertical and the connection, the support of the purlin to the frame. We have to pay attention what type of connection, what type of pulse, and what type of weld we will use. So here the panel will transfer the effort to the purlin and the purlin to the frame. And the frame here, if we have good space between purlin, we will have a uniform deformation. Because if the frame is charged in this side and this side is not charged, we can see that in the snow loads. So the deformation curve for the frame is not the same. So we need to support him from here more than from here. So we continue to draw to modify the purlin here the same way. So we have 20 and then 22. So it is not the same. It's not the same inclusion. It's not the same gamma here. So the same way I can copy this we have not the same offset too, so it's not geometry offset, so I can EBO, I can 2 for example, and I can try apply So here, and gamma is about so I need to modify so like that. I can do copy, so edit here, copy, and then we can do mirror vertical, so our model is okay. So here, as I have 30 degrees, it's unlaid in 30 degrees, so it receive more than the wind loss, and the frame receive normal forces more than the frame beside me.